All right. Thank you so much. So, today we will start with the chapter area under the curve. We have done enough in the definite integration. In the last class, we also covered definite integration as a limit of sum, and also we have done that Leibniz theorem. Okay, we have also done certain examples on inequalities. So, today we will start with area under the curve. All right. So, simply without talking too much about this, you guys have already studied certain things about area under the curve chapter in your 12th class. So today I will do few basic things. First of all, just to let you know how we do with the area under the curve. So this is the area of the region shown in the following figure. This one. Say if you see this figure. So the area we are talking about is this one. This area. Am I clear? And this area will be integration. See x from alpha to beta fx dx. That's it. Or simply area is alpha to beta y dx. Am I correct? So alpha to beta y dx. A very simple example over it, if we take, that is find the area enclosed by, find the area enclosed by, say x square plus y square equals to 16 above the x-axis. If I ask you, so above the x-axis, this is going to be your curve. This point is 4 comma 0. This point is minus 4 comma 0. Because this is a circle with center as 0, 0, radius 4, and they are asking you to calculate area above the x-axis. Now I simply told you what is the area. See, with just a geometry, we know it is pi r square by 2. But we want to calculate it using integration. So that is minus 4 to 4 pi dx or fx dx. So that would be minus 4 to 4. Y will be what? Under root of 16 minus x squared dx. See, this is a very prominent and highly useful formula in area. What you can do it twice using 0 to 4 under root of 16 minus x squared dx. Now we have this formula, that is x by 2 under root of 16 minus x square plus a square by 2 means 16 by 2. What if this is in the denominator? Then the formula is sine inverse of x by 4. Answer is from 0 to 4. Am I correct? Now, if you put the upper limit, this part will be 0. And another part will be 8 times sine inverse 1, that is pi by 2. Minus, if I put the lower limit, both will be 0. So answer is 8 pi, which it is already supposed to come. Because the full circle area is pi r square. So semicircle area is pi r square by 2, that is 16 pi by 2. So that will be 8 pi. Correct? So simple it is. Now, if the curve y equals to fx lies below the x-axis, all right, like this one. This curve y equals to fx lies below the x-axis, then area of the region bounded by this curve. Now simply what? Area will come negative because the definite integration will come negative. So what do? We finally take a modulus of the quantity you are finally getting. So area will be what? Either you can write from alpha to beta mod of fx dx, or you can do alpha to beta fx dx and mod of whole, because the entire curve is below the x-axis. Correct? Because the entire curve is below the x-axis. Vedant, are you getting? Vedant? Very good. Now, let's come to third curve. Sometimes we need to calculate the area enclosed by the curve and the y-axis. Area of the region as shown in the figure, bounded by the curve y equals to fx, y-axis, y-axis, and the line y equals to c to y equals to d. Now simply nothing much to do. Area will be what? Area will be integration c to d. The way we were doing it y dx there in the previous portion, here we will do x dy. Got it? Or if you can write the function of y in terms of x. Am I clear? Now see, the curve is something like sometimes it is above the x-axis and sometimes it is below the x-axis. But ultimately area has to be positive. Like if you are trying to figure out this area you are trying to find. So area as a formula will be written as integration from alpha to beta mod of fx dx. Getting my point? But the problem is from alpha 1 to alpha 2. In this interval, area is going to be, because definite integration is going to be negative. So to make the area positive, you have to apply mod. So for that case, we will be breaking this integration as alpha to alpha 1 fx dx, because fx is positive. Then alpha 1 to alpha 2, it will be minus of fx dx. And then alpha 2 to beta, it will be again fx dx. This much of hard work we have to do. And to get through this, you have to identify what are the roots this function is having. Got it? Like for example, if I take fx equals to x cube minus 6x square plus 11x minus 6. So find the area enclosed by x equals to 1 to x equals to 3, say x equal to 0 to 3, 0 to 3, where enclosed by x equal to 0, x equal to 3, fx and x-axis. All right. Now, if you see this curve is something like x minus 1, x minus 2, x minus 3. If I draw the graph of this, it will be like this. Sorry, I made a little mistake in the graph. Graph will be something like one root will be 1, then 2, and then 3. 1, 2, 3, this is 0. So they are asking you to find area this from 0 to 3, then this, and then this. Yes or no? So technically area should be integration 0 to 3 mod fx dx. But now see, between 0 to 1, this curve is negative. So you apply extra minus sign. So minus of x minus 1, x minus 2, x minus 3 dx. Then between 1 to 2, curve is positive. So it is x minus 1, x minus 2, x minus 3 dx. And between 2 to 3, it is again came below the x-axis. So you again apply negative sign, then it will be x minus 1, x minus 2, x minus 3 dx. Now these are simple polynomials. You know how to integrate them. Am I clear? So this is how we find area of those curves which are sometimes above the x-axis and sometimes below the x-axis. Got it? Take a look. Now, now see if we have something like this. One curve is above the another curve. Okay, the question is like area of the region shown in the figure below, bounded between the curve fx, gx, where fx is less than gx, line x equals to a and x equals to b. They want you to find out this area. Got it? So simply nothing much to do. Okay, one more thing. Even if the graph is something like this, that this is your gx and this is your fx. Gx is above the fx. This is x equals to a. This is x equals to b. You are trying to find this area. All right. Even if the graph is something like this, when both the curves are below the x-axis, but still gx is above fx. This is x equals to a and this is x equals to b. So simply in all these cases, area will be what? From a to b, upper curve minus lower curve dx. Gx minus fx, it will be. Gx is above x-axis. Gx minus fx dx. But sometimes if the case is like this is your gx and this is your fx. And you are trying to figure out the area bounded by these two curves from x equals to a to x equals to b. And what is happening that these two curves are intersecting somewhere in between at x equals to c. So basically this area they are asking you to figure out bounded by these two curves from a to b. So area will be what? A to b gx minus fx mod dx. So between A to C, above curve is gx, then it will be gx minus fx dx. And between C to B, above curve is fx, so it is fx minus gx dx. Am I clear? So you have to notice which curve is above, which curve is below. And accordingly, we find the answer. Now, area of the region shown in the figure, in the following figure, bounded by the curve fx gx x-axis and the line x equals to a and x equals to b. Now simply nothing much to do. You have to find out this area. So again, you have to figure out the point of intersection of these two curves. Then between A to C, fx area, and then C to B, gx area. Am I clear? Have a look. Got it? Now, without investing much time, let's start with few questions. So this is your first question. Start it. The area bounded by the curve 4y square is equals to x square 4 minus x minus 2 is equals to. Quickly do it. Yes. Area bounded by this curve. I'm launching the poll. I think few of you must have started attempting it. Yes, do it. Area bounded by the curve 4y square equals to x square into 4 minus x, x minus 2. And this is a good question. Yes, others also please attempt. Very good. We got two answers. Quickly, others also try. Well, now let's do. Three people answered. All three answered C. And I think C is the correct answer. See, the question is this. 4y square is x square into 4 minus x, x minus 2. So can you say that this y is mod x upon 2 into under root of 4 minus x into x minus 2. If I want to see the domain of this function, so for that, this 4 minus x into x minus 2 should be more than 0. Definitely plus minus sign will also come. And now this is no more a function. This is just equation. So for this, that will be x minus 2 into x minus 4 less than equal to 0. So your x lies between 2 to 4. Am I correct? This x lies between 2 to 4. So between 2 to 4, this y, exactly what it is, I have no idea. But it will be something like this. And because of y square, this function is symmetric about the x-axis. So the way it is above the x-axis, the same way it will be below the x-axis. Got it? The way it is above the x-axis, in the same manner, it will be below the x-axis. So the area that you are going to find is 2 to 4 x upon 2 under root of 4 minus x into x minus 2. This will be the area above the x-axis, and then you make twice of that. That will cover the area below the x-axis also. This is basically what? Area y1 minus y2 dx between 2 to 4. y1 is the positive curve, y2 is the negative curve. So if I subtract them, I get twice. Am I clear? So this area is basically between 2 to 4 x under root 4 minus x, x minus 2. Now see, the sum of the limits is 6. So if you apply that property 4, so between 2 to 4, it will be 6 minus x under root 4 minus, if you do 6 minus x, it will become x minus 2 and it will become 4 minus x. Got it? Now if I add both of them, 2a will be 2 to 4, 6 times under root x minus 2 into 4 minus x. Am I clear? So it is 2 to 4, 6 times. I can write it 4 to the 8 minus 8 minus x square and plus 2x. Yes or no? No, plus 6x, sorry. Plus 6x. Now you subtract minus 1 and you add minus 1, 4 to the 8. Subtract minus 1 and add plus 1. Then you will get integration 2 to 4, 6 times 1 minus x minus 3 whole square. Got it? Now integration formula also we can use, but you can simply see that this curve, if I see in the rough, this curve y equals to 1 minus x minus 3 whole square under root. This is what? This is y square plus x minus 3 whole square equals to 1. So this is a circle of radius 1 and center 3 comma 0. This is it. So they are asking for 2 to 4. So they are asking for this area of semicircle. So we can be little quick in this case. 6 times pi into 1 square upon 2. Got it? So it will come 3 pi. Now, fortunately, 3 pi is not an answer because most of the kids must have marked it. Now you got 2a as 3 pi. So a is 3 pi upon 2. This is your area. Am I correct? Christina? Priyadarshini? Did you get that? Bhagat? Bhagat? Bhagat, can you switch on your mic? Then switch it on.
Yes, sir.
Bhagat, did you understand it?
Yes, sir.
Totally?
Sir?
If this question comes in exam again, will you be able to do it on your own?
Yes, sir.
Very good. Well, now try this question. The area of the part of the circle which is outside this parabola. Area of the part of this circle which is outside this parabola. See, this chapter requires a prerequisite that you should know all the basic graphs of circles, parabola, ellipse, hyperbola, logarithmic functions, exponential functions. At least this should be known to you. Am I correct? Anyways, start with this. Area in the square unit of the part of the circle which is outside the hyperbola. The poll I'm launching now. Go for it. Yes. Yes, try it quickly. Give your best. Others also try. Well, now let's end this. Two people answered, one answered A, one answered B. And now, Sivamani, Sivamani, see, this is the kind of circle you are having. All right. And the parabola that they have provided us is this. That is y square equals to 9x. Now you have to figure out this area. All right. So first of all, to get this area, I have to find out these 2 points. So solve y square equals to 9x and x square plus y square equals to 36. So it is x square plus 9x minus 36 equals to 0. 12 and 3. So it will be x plus 12 into x minus 3 equals to 0. So value of x you got as 3. See, minus 12 is not possible. So here value of x is 3. So this line is what? This line is x equals to 3. Am I correct? Now see, this particular part, this is a semicircle. So this area I can write manually since it is an objective paper. Nobody is seeing if you have calculated it using integration or not. So your area will be half of the circle area, that is pi r square. So 36 pi by 2. This is half area plus. Now what I will do, I will find this area. And from this area, I will subtract the area of this parallelogram. Oh, sorry, area of this parabola and then double it because same area is below the x-axis. All right. So this area is, first of all, circle. Circle is under root of 36 minus x square minus parabola. Parabola will be 3 root x dx. Limits from 0 to 3 and double of this. I hope everybody must have got it. So in the area of the circle, I added the area enclosed by the parabola. So enclosed by the circle except parabola. So area will be C. 18 pi is this plus 2 times. Now use the formula for integration. That is x by 2 under root of 36 minus x square plus a square by 2 means 18. This will be sine inverse of x by 6 minus 3 times root x integration is x to the power 3 by 2 upon 3 by 2 and limit from 0 to 3. Got it? See, fortunately at x equal to 0, everything is going 0. So what you have to do, you have to do it x equals to 3 only. So it is 18 pi plus 2 times. Now place the upper limit. It will be 3 by 2 under root of 36 minus 9. 36 minus 9 will be 27 plus 18 times sine inverse of 3 by 6, matlab means 1 by 2 minus 2 times. This is x raised to the power 3 by 2 means 27 under root it will be. Got it? So it is 18 pi plus 36 times pi by 6 plus 3 minus 4. So it will be minus of root 27. So that is 18 pi plus 6 pi. So 24 pi minus 3 under root 3. Twenty-four pi minus 3 under root 3. Got this? Am I clear? Have a look. Now, let's go with this question. Start over. Consider the region R, x square less than y less than equals to 2x. If the line y equals to alpha, divide the area of region R into two equal parts, then which of the following is correct? Such a good question it is. Now there is a poll for you. Yes, start. Yes, anybody? Let's see, this is a tough question undoubtedly. First of all, the prediction of graphs is a bit difficult. क्या कर रहे हो? मत करो। क्या? क्या कर रहे थे? Yes, guys. Anybody? All right, I'll do it. See, the question is consider the region R. So there are two curves. One is y more than or equals to x square, and other is y less than or equals to 2x. Am I correct? Now, see, this is the curve y equals to x square. Yes or no? And the line will be something like this. This is the line y equals to 2x and this is y equals to x square. So this is the area they are talking about. Above the parabola, below the line. All right. Now there is a line y equals to alpha. There is a line y equals to alpha, which is dividing this region R into two equal parts. Got it? This line y equals to alpha is dividing the region into two equal parts. If you solve for this point is going to be 2, 2. Sorry, 2, 4. This point is going to be 2, 4. Correct? Now we will find out this area along y-axis. Am I clear? So integration 0 to alpha. Integration 0 to alpha. Now the above curve will be under root y minus below curve line will be y by 2 dx. It is equals to integration alpha to 4. Again above curve is root y minus y by 2. Sorry, this is dy. This is also dy. Am I correct? Now you just simply integrate it. It is y raised to the power 3 by 2. Here it is 2 by 3 minus y square by 4. Limit 0 to alpha is y raised to the power 3 by 2 upon 3 above 2 minus y square by 4. And here limit will be alpha to 4. Now if you put the upper limit, it will be 2 times alpha to the power 3 by 2 upon 3 minus alpha square by 4 is equals to 2 times it will be 8 by 3 minus 1 minus 2 times alpha to the power 3 by 2 upon 3 minus alpha square upon 4. So it will become plus alpha square by 4. So this will be alpha square upon 2 minus 4 times alpha raised to the power 3 by 2 upon 3 plus 16 by 3 minus 3, that is 13 upon 8 to the 16, 13 by 3, just a moment, 4 alpha, okay, this is 4, not 1. So it is 4 3 to 12, 8 to the 16. So it will be 4 by 3 plus 4 by 3 equals to 0. Now you multiply this equation by 6, you get 3 alpha square minus 8 times alpha to the power 3 by 2 plus 8 equals to 0. Got it? So this is how it works. And with this, we got the answer. Like 3 alpha square minus 8 times alpha. This Bombay is the correct answer. Got it? Tell me, is it clear to everybody? Got it? Now, try this way. The area in square unit of the region y less than equals to x square plus 1, y less than equals to x plus 1, and x lies between 1 by 2 to 2. Yes. Take your time. And mark your correct answer in the poll section. Yes, quickly. Okay, we got an answer. Anybody else who gave this answer? Raise your hand. Who gave this answer? Bhagat? Bishan, did you answer it? Yes, others will try it quickly. Let's call it an end. Let's do it. Area of the region. See, now there are two curves. One is y equals to x square plus 1. Other is y equals to x plus 1 and x lying between 1 by 2 to 2. See, this y equals to x square plus 1 is this kind of graph. This is y equals to x square plus 1. And here y is less than x square plus 1 means it is going below this line. All right. Now, y is x plus 1. So at x equals to 0, this graph is going with this point. At x equals to 1, they both are 2. And then line goes below, curve goes above. This is like this. 1 and say this is x equals to 2. So y is also below the line, y is also below the curve, and x lying between 1 by 2. 1 by 2 is somewhere here. 1 by 2 to 2. So 1 by 2 to 1, you will be having this graph, which is x square plus 1. And 1 to 2, you will be having this graph, which is below the line. So area will be what? Integration 1 by 2 to 1 x square plus 1 dx, and between 1 to 2 it will be the line x plus 1 dx. Am I correct? So 1 by 2 to 1 it will be the parabolic curve, and between 1 to 2 it will be simply x plus 1. So this goes like x cube by 3 plus x limit 1 by 2 to 1, and here it is x square by 2 plus x. Their limit is 1 to 2. Now it is 1 by 3 plus 1 minus. Now if you put x equals to 1 by 2, it is 1 by 24 plus 1 by 2 plus 2 plus 2 minus 1 by 2 minus 1. This should be your answer. So it is 4 by 3 minus 13 upon 24. Yes. Plus 4 minus 1, 3 minus half, 5 by 8. If I take its LCM as 24, 3 8 are 24, 8 4 are 32, minus 13 plus 60. So 60, 92 minus 13, 92 minus 13, 79. 79 upon 24. Got it? Very simple, good, sober question. Am I clear? Now, we'll go with this one. Area of the region enclosed by the curves y equals to x square minus 1 and y equals to 1 minus x square is equals to. Have it, give it a try. Yes, quickly. So there you have the poll. Just mark your answer. I won't be able to give you much time, just couple of minutes to attempt quickly. Yes, guys, be quick. See, nobody has answered, and almost 1.5 minutes done. This is a pretty easy question. Now there is a curve y equals to 1 minus x squared. All right. So this is parabola having roots as -1 and 1. And minimum value as -1. Other one is y equals to 1 minus x squared. They are simply negative of that, so it is this graph. Like this. This is 0, 1. So what we will do, I will calculate this area. And then double of that because the same area is below the x-axis. Or if you don't want to do is, you simply subtract the two curves. So area will be what? Integration -1 to 1, y1 minus y2 dx. So -1 to 1, upper curve is what? 1 minus x square. Minus lower curve is what? X square minus 1 dx. So between, say, we do it twice, 0 to 1. So it will become 2 minus 2x square dx. So that is 4 times 0 to 1, 1 minus x square dx. 4 times x minus x cube by 3, limit 0 to 1. So it is 4 times 1 minus 1 by 3. So 2 by 3, your answer became 8 by 3. This is the easiest question out of all the questions that we have done today. All right. So this chapter is a huge ocean. There are multiple variety of questions, especially integration is no different, especially the way they are asking you questions. Like here, they are asking you in terms of inequality. So you also have to understand which curve is above the x-axis, which curve is below, which is, and sometimes another curve is above, another curve is below. So all these ideas you need to take care while attempting these questions. All right. So that would be all for the day. And we have done certain questions. You just need to practice more, practice more. That is the only ingredient for your JEE preparation.